Everyone, in this video we're going to talk about graphing exponential functions. We'll start with exponential growth functions. All depends on the base. In this example, y equal to 2 to the x, the base is 2, the base of the exponential function. If the base is a value greater than 1, you'll have exponential growth. Yeah, notice this function grows as x approaches infinity. It just gets higher and higher and higher, okay? Now, these graphs do have horizontal asymptotes. In this example, there's a horizontal asymptote at y equal to 0, right there along the x-axis. I plotted some points so you can get a sense of what's going on here. At 0 it's 1 because anything to the 0 power is 1. 2 to the 0 is 1. 2 to the third is 8. Even at negative 2. 2 to the negative 2 power is the same thing as 1 over 2 squared. Okay? I'm going to write that down. 2 to the negative 2 is the same thing as 1 over 2 squared. So what's going on at x equal to negative 2? It's at a value of 1/4. But this domain is negative infinity to positive infinity. See those double arrows? Let's do another example. Because all exponential growth functions look like this. How about y equal to e to the x? Now everyone, e is the natural base. E is a value. It's an irrational number. It's 2.7182818 ... Yeah, it says y equal to parentheses 2.718 ... all raised to the x power. Well, this graph of y equal to e to the x will look just like this. All right? The horizontal asymptote will be at y equal to 0. We'll plot one point. Yeah, the y-intercept. What's going on at the y-intercept? Set x equal to 0. E to the 0 value is a 1. Yeah, e to the 0 is 1. So I'll plot that. And this graph will look just like that one. And it's a rough sketch. That's y equal to e to the x. Okay, y-intercept at 0, 1. We just want to get a rough sense of what's going on with the sketch. Now, these graphs can shift vertically. So, let's look at a couple more examples. Yeah. Just like y equal to x squared plus 1, the graph of y equal to x squared shifts upward 1. Let's look at y equal to 3 to the x minus 1. And let's look at y equal to e to the x plus 2. And we'll make rough sketches of what's going on here. Do we have exponential growth? Yes, the base is higher than 1. E is 2.718. The base is higher than 1. We have exponential growth. All right, now, we're going to make rough sketches like the last ones. We'll start with the horizontal asymptote. All right. And when this is real easy, this right here, that minus 1, 3 to the x minus 1, this minus 1 will tell you exactly where the horizontal asymptote is. This graph just shifted downward 1. The graph of y equal to 3 to the x. So the horizontal asymptote will be located at negative 1. Let's get one point. How about the y-intercept? It's a nice point. Set x equal to 0. 3 to the 0 power is 1. 1 minus 1 is 0. So this graph will intersect right there at the origin. And I'll just make an exponential growth. There we go. Yeah, that's simple. All right, let's do the same thing here. All right, what's the horizontal asymptote? There it is, see it? The horizontal asymptote is the equation y equal to 2. So yeah, e to the x just shifted upward 2. There it is. There's your horizontal asymptote, the y equal to 2. Let's get one point. How about the y-intercept? What's going on at the y-intercept? I'll put it down here. The y-intercept is where x equals to 0. E to the 0 plus 2. 1 plus 2 is 3. So this will be up at 3. This graph will just a rough sketch. Now let's talk about exponential decay. Because not all exponential functions grow. It all depends on the base. Remember, these bases are higher than the value of 1. So guess what? What if the value of that base is between a 0 and a 1? Something like a half, or a third, right? Or 0.7, or 0.8. Everyone get that? Let me get this word growth out of here. If your base of your exponential function between 0 and 1, you have exponential decay. So you want to make a rough sketch of this? Sure. Let's see. Horizontal asymptote, nothing's here. Horizontal asymptote is right on the x-axis. The horizontal asymptote is the equation y equal to 0. Let's get 1 point. How about the y-intercept? What's going on at x equal to 0? 1/2 to the 0 power is 1. But don't forget, you got decay. This base is less than 1. So this graph will decay. This graph will approach this horizontal asymptote as x goes towards infinity. This function. Okay? Yeah. Y equals 2 to the negative x. Be careful, everyone. While 2 is greater than 1, it's raised to a negative x. And recall, 2 to the negative 1 is 1/2. So, right here, we don't have growth. This is decay. In fact, this is the same as this, okay? Where's this sketch? Right there, okay? Be careful with that. One last example. Y equals e to the negative x plus 1. Okay. Horizontal asymptote. Set y equal to 1. There it is. The equation of y equals 1 is where the horizontal asymptote is. Let's get 1 point. How about the y-intercept? And the y-intercept, set x equal to 0. E to the negative 0 is the same thing as 1 over e to the 0, which is 1. 1 plus 1 is 2. This is located right here. But everyone, this is not growth. E to negative x. That's the same thing as 1 over e to the x. 1 over 2.7, 1828, dot, dot, dot. Everyone is less than 1. So yeah, when you see a negative exponent, it's a good indication that you'll likely have a decay function. This function will go down like this. There's a rough sketch. Yeah. And that's it.